All right, so today we're going to talk a little bit more about lines and slopes and then parallel and perpendicular lines. So what we're going to do is we're going to fill out this table. So again, like I said, if you want to draw this table in your notes, it's probably the best method. And then I'm going to kind of explain each piece to you. So first of all, these equations right here are in slope-intercept form. Do we all agree with that?
Yes.
By slope-intercept form, what I mean is y equals m times x plus b. Once again, the y represents the y value in an ordered pair. The m represents the slope. The x represents the x value in the ordered pair. And the b represents your y-intercept. Is everybody okay with that? Cool? All right, so first of all, this first section, can anybody tell me what the y-intercept of this equation is? Brian? Now, I know yesterday we talked very, very, very strongly about not having y-intercepts. Doesn't mean they don't appear anymore, it just means for that particular lesson. Can anybody tell me what the slope of this equation is? Ben? 4. Now notice that Ben did not say 4x, because 4 is the x value. 4 is the slope. The x is the x value. Now, somebody tell me, what is a parallel line? Like, if I was going to describe parallel to somebody, how would I do that? How would I describe parallel? How would I do it? Katie?
Lines that don't cross.
Lines that go on forever, never, never, and don't ever cross. So, for instance, these two L's right here are parallel lines. Railroad tracks, the lines on the street, all that good stuff. Can we agree with that? Okay. I'm going to let you guys think about this for a second. What do you think a parallel line, what do you think a parallel slope to 4 is? Think about it. Work on it. Convince me. Draw it on your paper. What do you think another line slope would have to be parallel to this line? What do you think another line slope would have to be parallel to this line? Charger, I saw your hand up first. What do you think? Negative 4? I disagree. Xander, what do you think?
Positive line.
A positive line? It will have to be a positive line, but I want to know specifically what will the slope have to be, Brian? 0? Well, let's think about it. If I have a 0 line, that means I'm going straight across. And if I have a line that's 4, aren't those going to intersect? That's not parallel. What do you think, Aiden?
The same slope, but different y-intercept.
Ah, beautiful. Well done. Let's talk about that. Okay. I'm going to draw a coordinate plane here. I'm going to graph this line. Is everybody okay with that? So we're going to start at 2. We're going to go up 4. 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. Okay. Now let's think about it. If this line is parallel to this line, doesn't that mean that it has to increase at the exact same amount of time as the previous line? But why does it have to have a different y-intercept, Hayden?
Because if you have the same, it's going to be right on each other.
Do you agree with that? If I ask somebody else to come up here and graph this same line, wouldn't it just be the exact same thing? So if we did it the other way, if we change the y-intercept, let's just say we change it to negative 2 just for simplicity. We're going to go up 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Don't y'all agree that's a parallel line? Okay, so somewhere in your notes, I want you to add this. Parallel slopes. Parallel slopes. Same slope. Different y-intercept. Same slope, different y-intercept. When you're done, I want you to set your pencil down so that I'll know that you're done. Okay, now I want you to write it 3 more times. Parallel slopes. Same slope, different y-intercept. Parallel slopes are same slopes, different y-intercept. You should have it written down a total of 4 times. Parallel slopes are same slopes, different y-intercepts. Same slope, different y-intercept. Hayden, well done on that one. Well done.
That was a way double trick question.
In a way, but you figured it out though. So parallel slopes are the same slope but a different y-intercept. Parallel slopes are the same slope but a different y-intercept. I know it seems redundant that I'm making you write it so many times, but gotta do it somewhere. Gotta practice somehow. All right, so let me ask you this question. What is the slope of a parallel equation? It's the same. So what is the slope of the parallel equation? 4. All right. Everybody feel pretty good about parallel at the moment. All right. What does it mean if I have perpendicular lines? What does it mean to have perpendicular lines? Stone, what do you think?
Two lines cross and they make like all like triangles.
Yeah. 2 lines cross and form 4 right angles. So let me just give you a couple examples. Perpendicular? Perpendicular? Okay. What about if I gave you, is that perpendicular? No, because it has to form 4 right angles. So if you don't understand that perpendicular means 4 right angles, make sure you get that acknowledged. All right, let's put another game here. Can anybody tell me what the slope's going to be of a line that has perpendicular lines? It's much more difficult for the parallel, but there is a very nice, easy answer. AJ, what do you think?
What slope I have?
AJ, I'm going to try AJ this time. AJ, what do you think?
Alright, this is probably stupid, but I'm gonna go the inverse and say different slope, same y-intercept.
Okay, I would say some of that is correct, some of that is incorrect. Ben, what do you think? It does have to be negative sometimes. So again, not incorrect. Stone, what do you think?
Could you do undefined and 0?
You could. You could. That would work. Undefined and 0 would be perpendicular. Can we all agree with that? But there's another way for just random lines too. Tommy, what do you think?
So it would have the same y-intercept, but like this would have to be positive.
I do agree that if one line is positive, the other has to be negative. The y-intercept piece is not necessarily always true. Okay, I agree. One line has to be positive, one line has to be negative. I'll give you that. We're halfway there. What else do we need? The answer has been said. Someone has said it correctly already. What do you think?
Would it be the same y-intercept just like going down instead?
No, because if we're saying it's the same y-intercept, then that's implying that they're always going to cross with the y-intercepts. That's not always the case. They can cross other places. So we know that one line has to be positive, one line has to be negative, which is just common sense because if this line is positive and this line is positive, then they're going to cross at some point, but again, it doesn't make a 90 degrees, right? But if this line is positive and this line is negative, it means that they're going to cross perfectly. Stephen, what do you think?
Is it negative 4?
Getting warmer. Getting warmer. Let's graph it. I don't have perfect graph paper up here, but let's just take this. So if I go up 4, so 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1, and then I take a negative 1, because there's my line, and I go, we'll start at the same spot right here. 1, 2, 3, 4, 1, 1, 2, 3, 4, 1. Does that form 4 right angles? I don't think it does. I mean, that's not 90 degrees. That's way bigger than 90 degrees. Hayden, what did you just say?
The opposite of the slope.
The opposite of the slope? What's a better math term for opposite of a slope?
So if it's a positive slope, you want the same slope but negative.
Close. Steven?
The inverse.
It's the inverse. It's the inverse. Here's what I mean by that. If I have a positive 4, then we know that my perpendicular one has to be a negative, but what's the inverse of 4? Negative 1 over 4. Oh, negative 1 over 4. Okay? So for perpendicular, I'm going to add it up here. Opposite sign and inverse. Opposite sign and inverse. Opposite sign and inverse.
You mean perpendicular?
Yes. Thank you. Perpendicular. Might be.
Maybe. Do you want us to write this 3 more times?
Let's just write it 2 times.
Okay.
Only 2. Perpendicular is opposite sign and the inverse. 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 Opposite sign and inverse. Okay, so let me ask you this. If this is a positive for them to be perpendicular, number 1, we know it has to be negative. Good. And if we have a positive 4, what's the inverse of a positive 4? 1 over 4, right? Tomorrow, I'm going to show you guys how to graph this and prove all of these, but today we're just going to talk about this. All right, Bennett, what's the y-intercept of this one?
That 1.
1. Evan, what's the slope?
2 over 7.
2 over 7. Carter, what's a parallel slope to 2 over 7? It's a parallel slope to 2 over 7.
2 over 7.
2 over 7? Okay. Let's see here. Colin, what's a perpendicular slope to 2 over 7?
2 over 7.
Use this. Opposite sign, inverse. Ben, help him out.
Would be
Negative 7 over 2. Okay. Ian, what's the y-intercept of this one? 1. Katie, what's the slope of this one? Negative 1 over 2. AJ, what's a parallel slope to negative 1 over 2?
Negative 1 over 2.
Very good. That's a 2. I know it's very bad looking. Charger, what's a perpendicular slope to negative 1 over 2?
Positive 2.
Yeah, nice. Very good. Does everybody see how he did that? He knew it was negative, so he made it positive. That's the first step. It was 1 over 2, so he flipped it, which became 2 over 1, but 2 over 1 is the same thing as 2. Okay? Zoe, what is my y-intercept on this one? Negative 13. Cleo, what's my slope on this one? Negative 9. Let's see here. Zandon, what's a parallel slope to negative 9?
This one's pretty tough. I think it's negative 9.
Well done, well done. And Tommy, what's a perpendicular slope to negative 9?
Positive 1 over 9.
Yeah, well done, y'all. Well done. Very good. Let me stop this video real quick. Okay,